In this video, we are going to revise graph interpretation of linear graphs. So, going straight into an example, it says given f of x equals negative a third x plus 3. So, you are given the function there and you are given the graph. Okay, give the value or values of x for which, and then we have these typical types of questions where f of x equals 0, or where f of x is greater than 0, or where f of x is less than or equal to 0. Okay, now the first thing you need to know about these types of questions is that you will always answer in terms of x. Okay, so it will always ask you, give the value or values of x. Okay, the next thing is that you must interpret this question. Okay, you must understand what it's asking you for. Okay, so to help you do that, remember that the function notation f of x can be replaced with y. So this is actually asking you, where is y equal to 0? So once you understand that, you use the y values to find the place on the graph where your answer will be. Okay, so y equals 0 is over here. So horizontally, if we find the graph, y equals 0 at this point here, which is our x-intercept. Okay, so you use the y value to find the correct part of the graph, and you always answer with the x value. Okay, so here the x value is 9. So our answer is therefore x equals 9. The next question says, where f of x is greater than 0. Now, f of x, remember, can be replaced with y. Now, where is y greater than 0? Greater than 0 means positive. So where are the y values positive? They are positive above the x-axis. Okay, so understand the question, then find that part of the graph that has positive y values. Find that part of the graph, and this part of the graph here, any point on this line, this part of the line here, will give you a positive y coordinate. Okay, and remember that it carries on in that direction. So we use the y values to find the correct part of the graph, but we always answer in terms of the x values. Let me just get rid of all of these horizontal lines, because for my answer I actually want the vertical lines which help me find the x coordinates of this part of the graph. Okay, now remembering that this graph continues, I'm going to continue to negative infinity, which means my x values are any x value that is less than 9. I don't include the 9 in this case because it didn't also say where y equals 0. Okay, so my answer here is just where x is less than 9. And for C, it says where f of x is less than 0. Remember, f of x can be replaced with y. So this is asking where the y values are less than 0, which means where they are negative. Now, that is on this part of the graph, below the x-axis. My y values are all negative. Okay, so I use the y coordinates to find the correct part of the graph, but my answer is always in terms of the x coordinates. So what are the x values here? So if I draw a vertical line, sorry, those are squiggles, to the x-axis, I find the x coordinates, and knowing that this graph continues until infinity. Okay, so the x values are any value that is bigger than 9, so greater than 9. And again, I'm not going to include 9 because it didn't also say equals to 0. So my answer, I answer in terms of the x coordinates, so it's where x is greater than 9. Okay, now where I only have one graph, okay, and graph interpretation questions like this, you'll notice that 9 appears in all of my answers. And the significance of 9 is that it is my x-intercept. Okay, so when I am doing graph interpretation for just one graph, the x-intercept is the most significant point. Now, here we have a graph interpretation question where I have more than one graph. Okay, so I'm comparing two graphs. And if we read the question, it says, given f of x equals 2x plus 1 and g of x equals negative x plus 4, give the value or values of x, there it is again, okay, for which, and then we have f of x equals g of x, f of x is greater than g of x, or f of x is less than g of x. Okay, so again, what you are going to do is understand the question relative to the y coordinates. Okay, then you are going to find the part of the graph using the y coordinates and answer with the x coordinates. Okay, so first of all, before we begin with the questions, notice that you're given the equations and the two graphs, but you're not told which equation relates to which graph. So that thinking you have to do yourself. Okay, so notice also I have one graph that decreases and one graph that increases. And we know an increasing graph has a positive gradient and a decreasing graph has a negative gradient, which means that my positive gradient 2 relates to the increasing graph. So this is f of x, and the negative gradient here, negative x, is for my decreasing graph. So that means this is g of x. Okay, so let's go to the graph interpretation questions. Okay, the first question says where f of x equals g of x. Okay, remember f of x is y. Okay, so the y coordinates of f must equal the y coordinates of g. Okay, now where does that occur? That occurs at the point of intersection. At the point of intersection, both graphs have the same y coordinate. Okay, so you must recognize this. Where one graph is equal to the other graph, it is asking you for the point of intersection. Again, understand the question, find the part on the graph, and then answer in terms of the x coordinate. So the point of intersection occurs where x equals 1. Okay. Question B asks where f of x is greater than g of x. That means where the y values of f are greater than the y values of g. So since y values are on a vertical line, okay, if the y values of f must be greater than the y values of g, it means where the graph of f is above the graph of g. Okay, so if I read from left to right, okay, at this point here, reading from left to right, g of x is greater than f of x. Where does that change? Okay, so as I move along my x-axis, looking at what's happening to the graphs, all along here, g of x is above f of x. Okay, but at x equals 1, things change. The graphs cross over, and after x equals 1, f of x is above g of x. Okay, which is what I'm looking for. And where does that change? Knowing that this graph continues forevermore and this graph continues forevermore, it means that for any part of the graph greater than 1, where x is 1, f of x will be above g of x. Okay, so find the part of the graph by understanding the question, but then answer in terms of the x coordinates. And this part of the graph relates to these x coordinates. So where x is greater than 1. So x is greater than 1. Okay. F of x is less than g of x. And let's just change this question to where f of x is less than or equal to g of x. Okay. So this is asking where f of x is less than or equal to g of x. So in other words, where the y coordinates of f less than or equal to g of x, that occurs where f of x is below g of x. Okay, now we've already said at this part of the graph f is above g of x, so it stands to reason that the rest of the graph might be the opposite. Okay, but again, read from left to right and see what's happening with the graphs. So at x equals negative 2, g of x is above f of x, at x equals -1, g of x is above f of x. At x equals 0, g of x is above f of x. Where does that change? At x equals 1, the graphs are equal, and beyond that, f of x is above g of x. So we just want to know where f of x is below, and that occurs in this part of the graph. Okay, so where x is less than 1. Okay, but I change it to also be or equal to. So where are the graphs less than f of x? Sorry, where's the graph f of x less than g of x? Where x is less than 1. But where's f of x equal to g of x? At equal. So this is x is less than or equal to 1. Okay, now this graph interpretation question you can answer directly just by looking and interpreting the graph. But I just want to show you that these same questions can also be answered algebraically, okay, simply by doing substitution. So I have the same graphs and the same questions, and I just want to show you how to answer these algebraically, okay. So given f of x equals 2x plus 1 and g of x equals -x plus 4, give the value or values of x for which f of x equals g of x. Answering this algebraically, what I'm going to do is write out what we're looking for and then substitute. F of x is equal to 2x plus 1. So in place of f of x, I substitute 2x plus 1. G of x is equal to -x plus 4. So I substitute that in there and I solve for x. Because remember, I want the values of x. So I'm going to solve for x. So I add x, so I have 3x, and I'm going to subtract 1. 4 minus 1 is 3, divide by 3, and I get x equals 1, which was the same answer we had found previously. Okay, so looking at B asks where f of x is greater than g of x. Again, just substitute. F of x is the same as is equal to 2x plus 1, and g of x is equal to -x plus 4. I have a linear inequality which I can solve for x. So remember, linear inequalities are solved like a linear equation. You just have to remember that if you are multiplying or dividing by a negative, to change the direction of the inequality sign. So 2x plus x gives me 3x. Greater than, subtracting 1, I have 4 minus 1, which is 3. Dividing by +3, so I'm not changing the direction of the sign, makes x greater than 1, which is the same as our previous answer. And likewise for C, okay, where f of x is, let's change this again to less than or equal to g of x. You're going to substitute 2x plus 1 in place of f of x and -x plus 4 in place of g of x and solve the inequality. Add x, so we have 3x, subtract 1, it's less or equal to 3, divide by x, and x is less or equal to, divide by 3, and you have x is less or equal to 1. Okay.